Okay, welcome to another video in the Edit training video series. In this video we are going to look at some of the tips and tricks and some of the other features when working in the Edit software. So we'll go ahead and we'll get right into it. Assuming you have Edit open on your desktop, you should be looking at a layer palette similar to this if you're working in the NanoFab. If you're not working in the NanoFab, it may look a little bit different. That's not really important. We're just going to pick a layer and we're going to start drawing some shapes. So the first thing that we're going to take a look at is the Boolean and grow operations. Now these operations allow you to perform logical operations on multiple layers and place the resulting polygon on a layer of your choosing. Now it should be pointed out that these Boolean and grow operations only work on polygons. That's the native shapes. That includes boxes, circles, toroids, and pi wedges. However, it does not include instances. So we'll just look at that in a quick second, how we can get around that. But let's assume we have some shape, and one of the common things that people want to do is cut holes out of a shape. So given a simple box here, we'll try to somewhat get it in the center of the screen. Let's assume that we want to cut out some holes in here. So selecting a different layer that we want to use, we'll just go ahead and we'll draw some boxes in here. Now again, this does not work with instances, so if we want to build this up a little bit, we kind of have to go the old-fashioned copy, cut, paste method, and we'll just give ourselves a few boxes here, like so. Now, in order to use the Boolean grow operations, what we're going to want to do then next is select all of the features of interest, and then right here is our Boolean grow shrink operation selector that we touched upon in the intro video, and I'll look at it in a little bit more depth. So opening up this dialog box, we can see that we have a couple of options. The result, basically what this is the resulting layer that we want our product to show up on. We'll pick layer 3 just so it's a little bit different. Next we have here is the operation that we can perform. So in here we have the logical operations OR, AND, XOR, and NOT. If you think back to your logic design, you should hopefully understand what these mean. I guess what we can do is we'll also throw up a little bit of a demonstration of all of these right after we go through this. We'll just give you a quick graphic. And the other ones that we have are grow and shrink and subtract. So for the first example here, maybe what we'll just do is we'll subtract. And I sometimes get these reversed depending which one's B and which one's A. So we're going to subtract 9 boxes on layer 2 from 1 box on layer A. So hopefully that works out the way we want. The next option here we have is to delete the inputs after the operation is done. Generally, you may or may not want this checked depending on what you're trying to do. We're going to leave it checked so our inputs will disappear. So we say OK, and we got nothing. All right, that is sweet. So we'll just undo that and go ahead here and reverse these to A minus B and try this one more time. There we go. So that's what we wanted to do. So this is our resulting polygon. So you can see that now we have on layer 2, which is where we chose to place our result, the product of that operation. So we'll just take a quick look at some of the other operations that we have available to us here. So if you wanted to see what an XOR looks like, it would look something like this. And the OR operation would be something like this. The AND produces something like this. And the NOT operation would look something like this. So in addition to those logical operations, the other things that we can do is grow or shrink features. So to do that, maybe we'll just slide over here to a different area and we'll grab a different type of polygon, something that looks some more features here to it, something like that. Now, just for reference, I'll just go ahead and throw something in behind it here, just so we can sort of get an idea of the size. I just put that there just for our own reference so we can see how this shape changes. But I'm only going to actually perform the operation on the first polygon here. So what we'll do then is we'll go ahead and click our Boolean and grow operations again. Now we get a little warning here on the inputs because we only have one object selected, and for subtraction it wants exactly two objects. So once we go ahead and we just select our, let's say, shrink, so what this is going to do is whatever number value you specify here, it's going to go around the perimeter of your polygon and shrink it by X number of microns. In our case, let's say 2 microns. And we will again place the result on layer 2, and we will delete the input when we're done. So what we should see is this polygon should decrease in size around the perimeter by 2 microns, and hopefully, yes, it did. So now we see that from our original starting point here, we've gone in 2 microns, and that has affected the entire shape. Conversely, we can do the exact operation if we wish to grow this feature, and so we can grow it by, well, let's say 4 microns. And now we're over by 2 microns all around. So that is the grow and shrink operations that you can perform inside the Booleans here. So grow, shrink, subtract, and the logical operations are all covered here. So that allows you to basically create more complex shapes than you could create. Actually, I shouldn't say than you can create. You can create these same shapes manually. It's just sometimes a little bit quicker to do it in this fashion. One other quick thing to point out here before we move on is that if you're working with curves or circles, if you watched the video regarding curves and circles, we talked a little bit about how the arcs and curves are affected by the manufacturing grid. So right now we are looking at a perfect circle. Of course, we know that that's not necessarily what we're going to get. Now, when you perform the Boolean operations, we'll just do an XOR here. When you perform the Boolean operations on curves, the result is going to be a polygon. So the arc that you get will be defined by the manufacturing grid. So in this case, our circle, once we're done here, we see is an approximation of a circle based upon the manufacturing grid. And the value that it uses for that is the instantaneous value of the manufacturing grid when you perform the operation. So if I was to go ahead and change the manufacturing grid now, I would not get any more precision or any more resolution out of this curve here around this circle. So that's a quick note just regarding curves when performing the Boolean operations here. So let's carry on to some of the other features in the Edit software. We'll start a new cell here and let's say import. Okay, so the next thing that we're going to take a look at here now is the layout generators. Now with the layout generators, you'll find those under the draw menu, layout generators, and there are a couple of them that we're going to take a quick look at. The first one is going to be the layout text generator. Now, oftentimes it's advantageous to place text markings on your mask, whether you want to designate sizes or numbers for various patterns or any type of information that you want to include on your mask, simple things, even your name, the date, what the mask is named. The way to do that is using the layout text generator. So what this will do is take your text string, for example, we can just use nanofab rocks, and we'll choose a layer. We'll use layer 1 as fine, that's the default. Now some of the other options here, the cell name. Now if you choose to create as an instance, which I recommend that you do, it's going to take this text string, convert it into polygons, place it inside of the cell, in this case text, it'll name that cell text, and then it's going to place an instance of that cell in our current working cell. So we'll go ahead and leave that cell as text. We'll create it as an instance. Then we have some other options here. We can automatically include the date. We can include a copyright symbol. We can underline it. If we have defined a company logo, we can print the company logo with this as well. And we'll snap to the manufacturing grid just for simplicity's sake here. Now the text size you see here, this is actually going to denote the line height. So we expect that our characters should be approximately 10 microns tall, give or take. So we'll go ahead and say OK to that, and it wants us to pick somewhere to put it. Let's say right about there is fine. Now we see a little quick blip there, and that's basically the Edit program includes a library of standard characters that it's going to use to build up our text. And we'll see the result here is a text built out of polygons. So sometimes it may look a little bit funky. As you can see here, we get some kind of oddities based on the font that's included by default. But if we note here, if we click this, this is a cell. It's instanced as text. And if we wanted to, we could descend down into this cell, and we could clean some of these spaces up here. If we were so inclined to do so, we could just go in here and make the necessary edits to this shape. Oh, self-intersecting polygon. We'll fix it. In any event, through a little bit of manipulation, we could include some stuff here and just clean this up. But our manufacturing grid's not really letting me right now. So we'll just move it by -1 and -1. Okay, how about 0.5 and 0.5? Something like that. The idea being that you can come in here and you can tweak these up to your liking. So we'll go ahead back up. So that's one way of placing text on your mask. Just as a note here, some people inadvertently use the port labeler to add text to their design. Hopefully it says something like "do not use this" when you try to implement this feature. But if your text looks like this nice black Arial text, this is not going to show up on your mask. And the only text that will show up on your mask should look like a polygon, like any other thing in your design. If you do use these port labels and attempt to export your design, you're not going to get any errors or warnings. It'll go ahead fine. But when it comes to the compilation, once you submit the mask for fabrication, this will generate warnings on the other end of things, and it will slow down your process and potentially cause you some headaches as you go ahead and try to solve these warnings. So don't use that. Use the layout text generator. Okay, the other way that we can add text to our mask, say we want something, for some reason we want some different fonts or something like that, we can convert formatted text to layout. Now what this will do is, in a similar fashion, we can choose which layer we wish to place our text on. The line height, again, we'll use 10 microns. But this time what we can do is we can choose from our system fonts. So whatever fonts you have on your system, you can take and you can have the tool render them as polygons. So let's find something kind of, I should have maybe just left it on the one I had. It was kind of scripty-ish. Well, let's hit cancel because I had a nice scripty one here. And now some of the other options that we have here are to merge the resulting polygons. So if you choose that, it can be a little bit more memory intensive, but what you'll get is, instead of a bunch of little pieces, you'll get sort of one polygon per letter essentially, or whatever it can do. So we'll say OK. And in that case, you see, it didn't turn out so good just because we chose a 10 micron line height. And so to implement that script, we see that we need to make our text a little bit bigger, which generally shouldn't be too much of a problem, as when you're adding text, it generally is larger. It's for you to see. So what we'll do is we'll just go back here and we'll increase this line height, say 50 microns. And then and there we go. So now we get a nice scripty looking font. And that is another way that you can add text. Again, this will show up on your mask, and you can place it on any layer you like. So those are two ways to include text in your design, should you wish to do so. Alright, so the next thing we'll do then is we'll take a look at importing images. So we'll make a new cell, images. Alright, so the next thing that we're going to take a look at here is importing images. So a lot of times you may want to include an image, a logo, a graphic, or even for example, your design may be, maybe you initially developed your design as an image, in an image format. Well, you can go ahead and you can import those images directly into LEdit, and that will save you a lot of time. So we can just use import image, and obviously what works best here is high contrast monochrome images. You can do color images. This software will try to sort of set some thresholds, and it will eventually become a monochrome image. But we'll start with a monochrome here. So we've got our University of Alberta Golden Bears logo here. And just to point out, the valid image types that you can work with here are GIFs, JPEGs, TIFFs, or bitmaps. So any of those image types are valid. So we'll go ahead and we'll stick with our Golden Bears logo. And again, we have some similar options here that we might expect to see. We can choose which layer we wish to import this image onto. And here we are given some control over the size of our image by specifying the height of each pixel. So you can play with this to get the image to the size of your liking. Some other things down here, merge resulting polygons. So basically, again, we can have the software automatically group our polygons. This is going to cut down on the eventual size of your file at the end of the day. Construct polygons from bright regions. This has to do with thresholding and contrast. And again, when you have grayscale images, the dithering here will affect the thresholds for cutoffs when it converts this image into monochrome. So we'll say OK. It's going to give us a warning here because we have quite a large image and it might take up a little bit of memory resources, so we'll say fine, that's okay. And that was actually pretty quick. So here we have our Golden Bears logo, and as we zoom out we see that it's been placed inside of a cell called logo Golden Bears and instance inside of our current working cell. And that's about it. That's as simple as it is to import images. Again, now you could descend inside and you can manipulate the individual polygons if you wanted to touch anything up or make any modifications if things didn't import quite as you expected. Sometimes you have to do a little bit of touch-ups. You can do that using this as well. So that is importing images, fairly straightforward, useful function within the software as well. So with that, actually, we'll just really quickly touch on one of the other things here just to determine the sizes of things. Now, when we imported this, we kind of just chose half a micron for a pixel height. But at the end of the day, if we want to know how big this ended up being, we can use our grid and whatnot. But we can also use temporary rulers, which are pretty handy. So a temporary ruler is created just by pressing T, and it will go in any direction depending on the tool you have selected. So, for example, if I just want to know the width of this thing, I can just hit T and drag it across, and I see that I'm at about 300 microns. Now hitting escape will clear that, and I can do a similar thing on the height, hit T, and I see that I'm at about 345 microns. So if I had a circle tool selected and I use T, then I'm going to be able to measure in radial directions. Or if it was an orthogonal polygon, then I'm only going to be able to go, I'm restricted to the angles of the tool that I have selected. If I happen to hit T a few times and I'm left with these straggling rulers, these temporary rulers, and I'm not sure how to get rid of them, that is under View, Display, Clear Markers. And that will clear off any of the temporary rulers that might have inadvertently stuck around a little bit. So those are temporary rulers, and that is importing images. The very last thing that we'll touch upon in this video before we wrap it up is some quick little trick in performing Boolean grow shrink operations on cells. So we'll get a new cell here, cell Boolean, we'll call it Boolean. Okay, so the last thing that we'll take a look at here before we wrap up this video is just a small little trick when it comes to working with Boolean operations and cells. So there may be many times when you wish to perform a Boolean operation on a cell. So suppose you have a pre-made cell. We'll just pull one out that we just made up a little earlier. And we want to perform a Boolean operation using this cell. So if we were to, say, give ourselves some substrate, let's say we wanted to cut this shape out of the substrate. Unfortunately, when we select everything and we try to perform the Boolean operation, it's not going to work. As mentioned earlier, this only does work on primitive objects. So this simple and short, easy answer is we can take this cell, and by ungrouping it or flattening it, what we do is now we have extracted that information out of the cell, and now we're working with our raw polygons again. So we can now take this and create our operation. We're not going to delete the inputs this time because I want to keep that feature. And we'll place the result on a different layer just so that we can manipulate it a little bit easier. And we will perform subtraction. And hopefully we get the order the right way here this time. And it looks like, again, I got it backwards. I managed to do that every single time. So I'll swap that around, and there we go. So now if we just hide layer 1 for a second, where's our object on layer 3? Okay, I guess I chose layer 1. Yeah, it doesn't matter. We want to get rid of that one. And here's our resulting object on layer 1. So that is the simple way to get around Boolean operations with cells. Now another thing that we can do here, just to show, get only this one, and we will perform a shrink, and let's just shrink it by 1 micron, and we'll just pull it back from the edge. And again, I forgot to uncheck the delete inputs when done. So now we've created our shape, and one little thing to note is that this has not impacted our original shape, as we had ungrouped that cell, so those changes that we made did not impact this. However, now if we wanted to take this shape, we could copy it and paste it into here, and now we've modified this cell so that those changes will be reflected through our hierarchy. So that is the short and simple way of modifying cells in order that you can use the Boolean operations on them. And that is going to wrap up this video. Just a couple of tips and tricks when manipulating objects in LEdit. Thanks for watching, and we'll see you next time.